Hello all. So today we are continuing our discussion in chapter 6 over biomechanical principles, and this is part 3. So movements are governed by mechanical principles. Biomechanists use these principles in the analysis of movement. Stability is an important factor in all movement skills. It is related to equilibrium and balance. When all the forces acting on the body are counterbalanced by equal and opposite forces, so that the sum of the forces equals 0, equilibrium is maintained. A state of equilibrium occurs when the body's center of gravity is over its base of support and the line of gravity, which is a line that's drawn from the center of the gravity to the center of the earth, falls within the base. The base of support of the body is the area outlined when all the points in contact with the ground are connected. The greater the body's surface in contact with the ground, the larger the base of support. Thus, a sitting position has a larger base of support than a standing position. Rather than just 2 points, as in standing, typically increases the base of support. A stance that places 4 points of the body in contact with the ground. Stability is the body's ability to return to a position of equilibrium after it has been displaced. The greater the body's stability, the more difficult it is to affect its equilibrium. Static equilibrium occurs when the center of gravity is in a stable position, such as when one is sitting or performing a handstand in gymnastics. Dynamic equilibrium is a state in which the center of gravity is in motion, such as when one is running or performing a cartwheel in gymnastics. In sport and movement terminology, stability is often referred to as balance. The body's ability to maintain stability or balance is governed by 3 primary principles. The law of inertia states that a body at rest will remain at rest, and a body in motion will remain in motion at the same speed and in the same direction unless acted upon by some outside force. For a movement to occur, a force must act on a body sufficiently to overcome that object's inertia. If the applied force is less than the resistive force offered by the object, motion will not occur. Once an object is in motion, it will take less force to maintain its speed and direction or momentum. For example, it takes an individual more effort to start pedaling a bicycle to get it underway than it does to maintain speed once the bicycle is moving. The heavier the object and the faster it is moving, the more force that is required to overcome its moving inertia or to absorb its momentum, assuming the time used to absorb its momentum is kept constant. In football, an opponent will exert more force to stop a fast-moving lineman than to stop the lighter weight and slower-moving quarterback. So the law of inertia is Newton's first law. Newton's second law is the law of acceleration and states that a change in velocity or acceleration of an object is directly proportional to the force producing it and inversely proportional to the object's mass. If 2 unequal forces are applied to objects of equal mass, the object that has the greater force applied will accelerate quicker. Conversely, if 2 equal forces are applied to objects of different masses, the smaller mass will accelerate quicker. For example, in shot putting, the athlete who is stronger and thus able to expend more force will toss the 12-pound shot farther than an athlete who possesses less strength. Also, an athlete who will find more force is needed to propel a 16-pound shot than a 12-pound shot. The heavier the object, the more force needed to speed it up. That is positive acceleration. Or slow it down, negative acceleration. And an increase in acceleration is proportional to the amount of force that is applied. The greater the amount of force that is imparted to an object, the greater the acceleration with which that object will travel. Momentum is a measure of both speed and mass. If the same amount of force is exerted for the same length of time on 2 bodies of different mass, greater acceleration will be produced in the less massive object. If the 2 objects are propelled at the same speed, the The more massive object will have greater momentum once inertia is overcome and will exert a greater force than the less massive object on something that it contacts. And then Newton's third law is the law of action and reaction, and states that for every action there is an equal and opposite reaction. Bouncing on a trampoline and springing from a diving board are examples of the law of action and reaction. The more force one exerts on the downward bounce, the higher the bounce or spring into the air. The thrust against the water in swimming is another example of an equal and opposite reaction. The water pushes the swimmer forward with a force equal to the force exerted by the swimmer on the backward thrust of the strokes. Whenever one object moves, another object moves too in the opposite direction. When you push something, it pushes back. When you pull on something, it pulls back. And here in the picture, you can see that in skateboarding, you have the action which you are pushing on the ground, but you have an equal reaction where the ground is pushing on you, which is one of the reasons we do a counter movement before we jump. A force is required to start a body in motion, slow it down, stop it, change the direction of its motion, or make it move faster. This is talking about linear motion. Linear motion is movement that is in a straight line and from one point to another. And this is a perfect example of linear motion. Rotary motion, on the other hand, is movement of a body around a center of rotation, the axis. And you can see with diving, again, a perfect example of rotary motion. Equilibrium. To have motion, the equilibrium of the body must be upset, which occurs when the forces acting on the body become unbalanced. A force is required to start a body in motion, slow it down, stop it, change the direction of its motion, or make it move faster. And leverage, something that we use in baseball. Efficient body movement is made possible through a system of levers. A lever is a mechanical device used to produce a turning motion about a fixed point called an axis. A lever consists of a fulcrum, which is the center or axis of rotation, which you can see here in the picture is the elbow, the elbow. A force arm, the distance from the fulcrum to the point of application of force, and a weight or resistance arm, which is the distance from the fulcrum to the weight on which the force is acting. The bones of the body act as levers, and the joints act as the fulcrums. The force to move the body or lever about the joint or fulcrum is produced by the contraction of the muscles. The length of the force arm and the distance from the axis to the active or applied force is the key to producing either force or range of motion and speed. If great force is desired, the force arm should be as long as possible. If range of motion and great speed are desired, the resistive arm, the distance from the axis to the weight, should be lengthened. The internal levers of the body cannot be controlled in regard to the length of the force arm. However, when using implements such as bats and rackets, a person can choke up on a bat and decrease the resistance arm. With the axis closer to the center of mass of the bat is easier to swing, and thus the batter should realize an increase in angular velocity. The smaller resistance arm decreases the linear distance through which the end of the bat travels, and depending on the change in angular velocity, this could have a positive or negative effect on linear bat speed. However, this strategy typically results in faster bat speeds. When using an implement to produce greater force speed, the size and the length of the implement must match the strength of the person who is handling the implement, which is one of the reasons why, especially with children, we'll use smaller bats and lighter bats. Levers are used to gain a mechanical advantage by producing either speed or force. Greater speed is produced by lengthening the resistance arm, and greater force is produced by lengthening the force arm. Levers enable one to gain a mechanical advantage by producing either strength or range of motion and speed. There are three types of levers that are determined by the relationship of the fulcrum, which is the axis, the weight, and the point of application of the force. We're going to talk about these next. In a first-class lever, the fulcrum is located between the weight and point of application of force. So you can see in the first example, you have the seesaw, where you have the fulcrum, which is the seesaw itself, and then you have the weight and the point of application of force, which is the person, their weight. And you can see that demonstration in the body here as well in A. With the neck in particular, it's a hyperextension of the neck, and the fulcrum is the neck with the weight, the resistance, if you will, where you're tilting the head back, and the point of application of force is down. The second-class levers produce strength, and third-class levers favor range of motion and speed. In a second-class lever, the weight is between the fulcrum and the force, such as with the wheelbarrow. You have the fulcrum, which is at the wheel, the weight, and then the application of force, which is you picking up that wheelbarrow. Another example of that anatomically would be with a calf raise, where you can see the ball of the foot is the fulcrum. The application of force is to lift the heel up, and the weight is in moving towards the calf. In a third-class lever, the force is between the fulcrum and the weight. The movements of the body are produced mostly through third-class levers. In third-class levers, the point of application of the force, which is produced by the muscles, is located between the fulcrum, which is the joint, and the resistance, which is the object to be moved. And here you can see a bicep curl, where you have the fulcrum is the elbow, the weight is the weight, and the application of force is the resistance, where you're trying to pull that weight up. Force is the effect that one body has on another. It is invisible, but it is also always present when motion occurs. It should be pointed out, however, that there can be force without motion. An example of a force in which no motion is evidence is the push against a wall by a person. The wall does not move, although great force might be exerted. Another example occurs when two arm wrestlers are pushing against each other with equal force, and their arms remain relatively motionless. Professionals should be aware of the principles relating to the production of an application and absorption of force when they teach movement activities. Body force is produced by the actions of muscles. The stronger the muscles, the more force the body is capable of producing. However, the force of the muscle group or the groups must be applied in the same direction and in proper sequence to realize the greatest force. In the high jump, for example, the body should be lowered on the last step before the jump. This lowering of the body will enable the jumper to contract the muscles under optimal conditions to create power. That's that law of action and reaction. The upward movement of the arms will give added force to the jump when coordinated with the upward push from the legs. It should be remembered that the principles of stability and the laws of motion must be observed in the performance of the high jump if the greatest height is to be attained. Force also must be generated to propel objects. The same principles apply as mentioned above. In the swing of a softball bat, the application of force is possible because of the production of force by multiple muscle groups in a coordinated manner. For example, for maximum force, the body should be rotated at the hips, shoulders, arms, and hands in a sequential order. The summation of these forces will produce the greatest momentum. A follow-through is necessary both to avoid jerky movements, decelerating prior to contact and to reduce the possibility of injury to the muscles or tendons. The force of an object is most effective when it is applied in the direction that the object is to travel. Many activities in sport involve the projection of the body or another type of object into the air. To project an object or the body forward most efficiently, the force should be applied through the center of mass of the object and in a forward direction. To move the body forward, the force should be directed upward through the center of the body. The example of the vertical jump will illustrate this principle. Force from the legs must be applied to the ground such that the upward reaction force from the ground is directed through the center of the body. If the jumper leans forward or sideways when pushing off from the ground, the force will cause rotation and forward or sideways motion instead of purely vertical motion, and the jumper will not jump as high. Many instances occur when persons must receive or absorb force. Examples include absorbing the force of a thrown object, as in catching a football or softball, landing after a jump, and trapping a soccer ball. The impact of the force should be gradually reduced, and it should be spread over as large an area as possible. Therefore, when someone catches a ball, the arm should be extended to meet the ball. During the catch, the hand and arms should give with the catch. When landing from a jump, the person should bend the hips, knees, and ankles to gradually reduce the kinetic energy of the jump, thereby reducing the momentum. The feet must also be spread slightly to create a larger area of impact or a base. And ideally, when landing, you want to try to encourage your athletes to land softly. Again, that's kind of to prepare the body for that impact. If they're slapping the floor every time, you can tell that's one of the signals is, and you need to encourage them to land softly. It will help to protect them. The more muscles that are used, the greater the force that is produced, provided, of course, that they are all working together. The more elasticity or stretch a muscle is capable of, the more force it can supply. Each working muscle should be stretched fully to produce the greatest amount of force. When objects are moved, the weight of the object should be pushed or pulled through the center and in the direction that they are to be moved. When objects are kicked, hit, or thrown, the force of the muscles should be used in a sequential manner. For example, the order in throwing should be trunk rotation, shoulder, upper arm, lower arm, hand, and fingers. When body parts, arms and legs, or implements such as bats and paddles are used, they should be extended completely when making contact with an object to be propelled. And when receiving or absorbing the force from an object, as in catching a ball, a fall, or a kick, the largest possible area should be used to absorb the force. For example, the student should use 2 hands to catch a hard-thrown ball. More area will be available to absorb the force of the ball. The absorption of force should be spread out as long as possible by recoiling or giving at the joints involved in the movement. And that is all we have for today, guys. Next, we're going to be talking about analysis of biomechanics. I look forward to talking to you soon. Have a great day.